Antibiotic resistance is when the bacteria are no longer affected by antibiotics that were once effective on it. I have here a bacteria, and you can see from the right my key that I have. The purple circles are plasmids, just so you're aware of what those are. And there are different ways that bacteria can become antibiotic resistant. You'll see that in different locations, I have my antibiotic, the red squares. And so the first thing that can happen is you can have an enzyme in the bacteria that will degrade the antibiotic. Remember that antibiotics, they're just chemicals. That's all they are. And so by having these enzymes come in, so there's enzymes that the bacterial cell makes, and those enzymes will come in and they will break down that antibiotic. Oops. And so in doing such, now my antibiotic is no longer together. It's kind of broken apart into all these junk pieces. So that's one way that the cell can do it, is by enzymatically degrading the antibiotic's chemical structure and thus rendering it useless, obsolete. So let's go ahead and we'll put some over here. And so then we can see that it comes in and it's going to, it should destroy. There we go. And so now what was our nice little squares there of antibiotic is now torn down and broken pieces. Another thing that can, I guess I should highlight that area green. So this is where that is acting at. It acted on the antibiotics that were in there. Another thing that can happen is there can be an alteration of the bacterial proteins. And so these light bluish gray squares are my bacterial proteins. And so what we're going to do is we're going to alter it. The enzymes are targeting, or the antibiotics are targeting certain proteins based on their structure. And we do know that it's not based on the shape. We learned in the immune system notes that it's the protein tags on the outside of the cell that get recognized. And so the antibiotic will recognize the proteins on the outside of the cell. They will enter the cell, and then there's bacterial proteins within the cell that it specifically targets. It specifically forces to malfunction. And what the bacteria does then is the bacteria will alter itself. The antibiotic, the red square, is looking for the blue-gray squares, but it is not looking for whatever shape this is. Oops. I'm just going to color this in. And so now my shape is different. My structure is different. It's looking for a certain folded protein, but instead it sees these test tube looking like things instead of the squares it's expecting. So because of that, the antibiotic is now no longer able to recognize its target. And the bacteria can still make those proteins that are essential to its survival, growth, and reproduction, and the antibiotic is no longer effective. The third main way that bacteria obtain antibiotic resistance is by changing the membrane permeability. We talked in the antibiotic notes that some of them specifically are beta-lactams, which are things like penicillin and amoxicillin, will poke holes in the peptidoglycan layer. Well, what the bacteria does is it will as the antibiotics come in, so antibiotics can enter through, let me change the size of that was a little redonkulous. They can enter in through the membrane by way of channels, things like porins, or sometimes they can get through the membrane, but usually through things like porins. They'll come into the inside of the cell. That's what gains them access to be able to attack the bacterial proteins, to degrade the bacterial plasmids, to do all those sorts of things. So what the bacteria does is the bacteria will sit there and say, as it notices that these antibiotics are coming in and are degrading pieces and portions of it. Remember, it's degrading small pieces and portions, so it's not like it degrades one and that's all there is, so it's immediately dead. It takes a lot of them. There's a lot of the different enzymes. There's a lot of the different bacterial proteins. There's a lot of the different plasmids. And so as the antibiotics come in, the bacteria soon start to recognize, hey, you're not supposed to be here, and it will block access. It will revoke access, kind of like a border control type situation. Another thing that it does is once it recognizes the chemical structure of the antibiotic as something that is harming it, it will use its efflux pumps, and it will actively pump the antibiotic out of the system. So it will actively push it out, decreasing the concentration of the antibiotic on the inside, which decreases its effectiveness, eventually allowing the bacteria time to become completely immune to that route or method. These are the three main ways that bacteria can become antibiotic resistant.